Hello and welcome to my channel. I'm Code Shepherd, and in this video we will talk about how the code is organized for a project written in C programming language. At the end of this video you will understand the structure of a project written in C, how the code is organized, and you will be able to do much better when you will have to manage your own project, or when you will have to explain these topics inside your team, or maybe when you will go to a job interview. I have prepared this demo project and I will use it to explain how a project written in C is structured. The C code is organized in files with extensions .c and .h, and for each C file there is usually a H file with the same name, of course. This pair of files is informally known as a module. The C files are not files containing set of functions. The key is to organize the code in several files and avoid cross-referencing problems. A cross-referencing problem is when a compiler complains because a symbol or a definition that is in a different file is not known. Usually, a big project contains a lot of units. These units are usually organized in something called components. These components fulfill certain requirements for that project. There is like a small functionality from the big picture, from the big project. So the smallest thing we have in a project, there is the unit, .h and .c. Okay, these are called modules. These modules are organized into components. As I see here, I made a component called component A, which has unit 1 and unit 2, and I made another component called B, which has the unit 1 and unit 2. And of course, every unit has its own hash file. Each module, as we see here, contains a set of functions, and the prototype, which makes the public interface, are defined in hash file. Let's take, for example, the component A unit 1.c. As we see here, this file contains a function called function A1. In the H file for this C file, we will see that we'll have here the declaration or the prototype of this function. The C file contains the implementations of these functions. As we see here, the C file component A unit A.c contains the implementation, the actual implementation of the function. And in some cases, additional variables or functions only accessible to the same C file. The prototypes of these functions are public. They can be used from outside the module and are included in the H file, so that the rest of the module may use it by including it at the top of the file with the directive include. For example, module main, the main file, can use functions from other modules by including their declaration. As we see here, we include the header file, header.h file, and header.h file contain the inclusion of each module header. Each module header contains the declaration of the functions that can be found inside the module itself. As we see here, we see the word extend. This tells the compiler that this function, it is defined somewhere else in another module, and at the linking stage from the compilation process, the compiler put all of these modules together, and actually the executable program it is created. The rest of the functions, the private ones, are included only inside the C file, defined with the static prefix, so that they cannot be invoked outside that file. For example, in unit 2 from component A, in this C file, we implemented a static function called function a2static, which can be called only inside this C file. If we try to call this function outside this C file, we are going to take a compilation error, because this function it is not be able to be called outside this module. This is what static word means. It means that this function it's only visible to this C file only, to this module only. Each C file must have at the top a directive to include its corresponding hash file, header files, right? For example, component B unit1.c needs, in order to compile and in order to not having any compiler error, needs to include its header file. This is done using the preprocessor instruction called include. We see here that we have two types of includes, using double quotes and using smaller than, bigger than signs. Well, this means that this header file studio.h, it is defined by the compiler. So it comes with compiler, and the header files that we include using double quotes, it means that when the compiler compiles the code, it will look for this file inside the folder that we found the C file. Long story short, these header files are written by us and we include them in our project, and these header files, they are from the compiler. But we use this in order to avoid inconsistencies between the definition of a variable and the prototype in the public functions in the C file and the declaration of its prototype in the header file. For example, this C file here, component B unit 1, we have the definition of function b1 and a definition of a b1 variable. In header files, which is in the header file which corresponds to this C file, we shall find the same declaration of this variable and these functions. As we see here, we have only the declaration of the we have here only the declaration of the function. If the corresponding H file, if the corresponding header file, it is included in the C file, the compiler can detect types conflict. For example, if we declare this function to not getting an integer as a parameter, but getting a char or a double in the hash file, we'll have a compilation error. The H file must contain only the public definitions, types, constants, global variables, and prototypes of functions to be used outside this module. Everything else must be included in the C file. For example, component B unit2.h, this header file here, contains the declaration of the B variable and the function b2. In order for these functions to be able to be called outside the module, outside the C file, component B unit2.c, we need to include their declaration inside the header file here, And these declarations here, not only the declaration, must be included in the C files that are going to call this function, that are going to call the functions from component to unit2.c, or to be able to use this global variable here. The component to unit2.h, it is included in the header file, as we see here. And this header file, it is included into main. So eventually, this header here, component b unit2.h, it is included into main. This is how main can, as we see here, alterate the value, so it can update the value of the b2, which is declared in this C file, and after that can use it. And this is how main.c can use this variable here, b2, which is declared in component b unit c, and can use it even to alterate its value, or to use its value in calculations or anything like this. Every H file must contain a guard in order to prevent multiple inclusions. Multiple inclusions means when we try to include in the same C file the same header file multiple times. This will result in compilation errors. A guard is implemented by surrounding the entire file content between if and def, and usually this macro is the same with the header name and the endif. So we use these preprocessor instructions in order to avoid multiple inclusions. We will see that every hash file, every header file from a project must contain this guard in order to avoid multiple inclusions. The header file must only contain the minimum set of include directives to compile their own code. For example, header.h includes only these header files which contain the declaration of the functions that can be found in the C files that they are assigned to. And because of that, in file main.c, we are able to call all the other functions that are defined in other C files. It is mandatory to define as static all private functions and variables. Static means that those variables and functions cannot be called or accessed from other C module. They are private only to this module. For example, function to static underscore static. It is a static function because it is defined with static before its name, and it is only visible to this C module. If other modules will try to call this function, we will get a compilation error. For example, if main.c wants to, let's put it at the end of the file, wants to call this function, we are going to get compilation error. Means that it is an undefined reference to function to static. All global variables in a module must be written at the top in order to be seen at once. When you open a certain module, the global variable from that module, from that C file, must be written at the beginning of it, because this way you will see it immediately and you will see what data can be used from that module. So you should avoid to define global variables and spread them all over your module. Well, as a consequence, it is highly recommended to separate the definition of a data structure from the declaration of a global variable of such type. For example, we have here a structure called data, and we have here the declaration of a global variable of the type structure data. In this function, in function a1, we initiate the members of this structure with different values, and then we print them. The declaration, not the declaration, the type definition from the data, it is not made here because this is a data type that we want to use in multiple modules. So I define this in another header file called public. So if I want to use this data type, this new data type, in a certain module, all I have to do is to include this header file here to that C module that in which I want to use this data type, declare variable, or I don't know, anything. So we see here public. It is a data. It is a header file which contains only the declaration, only the type definition for this structure, which has two members, and I included this public.h file in main.c. Yeah, in main.c, and I declare here a global variable of the type data, and I initialize the members of this structure with these values. And after that, I print their values here. Okay, let's now explain how this program works. We have this main.c file in which I include the header file, and in header file I include the other header files which are assigned to a certain module. Each header file here, unit 1 from component A, unit 2 from component A, unit 1 from component B, unit 2 from component B, contains the declaration of the functions that can be found inside the C module, unit 1.c from component A, and so on. This way, from main.c file, I can call or use the variables and functions that can be found in these C modules here. And this is how a project is usually structured. Long story short, in .c files, in C code files, we will find the definitions of the functions and the variables, and in .h file, in the header files that are assigned to each C module, we will find the declaration of them. Using these declarations from all these modules, we will be able to access functions or variables in a single file. In our case, main.c file. So basically, any of this C file here can use variables or call functions from other C modules by including their declaration. And of course, the declaration of each of these functions or variable must contain extern, because I will make in the future video about the compilation phases of a C project. But in the compilation phase called link editing, the objects that results from the compilations of each C file individually are eventually linked into a single module, into an executable file, and in this phase the compilator connects this extern here, the function used for example, in main, so this call here connects it to the actually definition of that function. Okay, let's first run the project. Let's first run the code and see what happens. So this happens after I run it. Let's go to main and see if our program behaves as we wrote it. Okay. The first thing that runs in a program when we execute it is the main function. In our main function here, we declared two local variables that we initialize them with some macros that are defined in the header. After that, we print on the screen, we print main function, and this is what we get here, main function. After that, we print these local variables, maxval and minval, and this is what we get here, maxval and minval. After that, we call the function a1 from component a unit 1. So this function here, it is defined in this C file, and we call it because we have all the references to it, and the compiler knows how to compile this code. Okay, so we call this function a1 var, and we give it as an argument, we give variable 1, which is a global variable declared in main.c. Let's go to this component. As we see here, this function 1, gets the parameter that we called from main.c file. Also in this file here, we declare another variable of type structure data. We initialize the members from that structure. We first print the a1 and the parameter a1. A1 is this global variable from component a unit 1, yeah, and we print them a1 equals 10, and the parameter that we called this that we use when we call this function. In our case, we use the parameter var1. Var1 is global variable in main.c, and if we do not initialize a global variable with a certain value, it automatically initialized with value 0. Okay. After that, after that, this function will also print the members of the structure that is declared as global here, and we see this value here, yeah. For ID is 444 and for value is 89.99. Good. The next thing we call in main.c is function a2, and we call it with var2 as an argument. Yeah. Let's go. Function a2, it is defined in component a unit 2. When we call this function, we will print on the screen a2 and the parameter we call the function with. So we get a2 equals 20, right? And the parameter is 300 because var2 is initialized with 300. Okay. After that, we change the value of the global variables from the main.c file. and we call the function b1 with variable 1. Function b1, the same, prints its parameter that it was called with, and also prints the b1 variable. After that, we have here this preprocessor instructions: if def call b2 and if. This preprocessor instructions verifies if we define the call b2 macro, and if we did, then this piece of code here will be included in the code which will be compiled. So call b2, we defined it in header file, in the header.h file, which is included into main.c. So we define this macro. So this code between these two hashtags will be included. So it will be eventually executed. So we have a call from b2, and we give the argument from variable 2. Variables 2 is 1 to 3, and b2 from this module, b2 is 40. After that, in our main.c file, we see here that we modify the variable b2, which is a global variable from unit b2, and we are able to access this variable from main.c because in header of b2 unit2.c, b2 variable is declared as extern. So if we include this header into other C file, that C file is able to access the global variable from the unit2, from the component B unit2.c file. So in this case here, any other C file that includes this header file is able to access this variable, even to use its value or to modify it, as main.c file does here. So we have another macro here. This time we have the if macro, and this macro checks the value of the call b2 again. If the value of this macro is different than 0, then the code that is between this if and if, it is included in the code that is going to be compiled and eventually executed. If call b2 again is equal to 0, this code will not be included. Call b2 again is a macro that it is defined in this header file here. So we defined this macro with value 1. So it's different than 0. So this code here is going to be included in the code that is going to be executed, compiled, and then executed. And that's it. This is our code. And this is, as you see here, function b2, it is called again, because this macro here includes the code. And after that, we wait for a user to press a key. And pretty much that's it. This is the whole project. This is the whole program. I hope you enjoyed, and see you next time. Bye bye. If you like this video and feel it was helpful, please press the like button, subscribe to my channel, and share this video with your friends.